So whenever we add or whenever we connect all positive to positive terminal and all negative to negative terminal. So what is this combination? What is this combination? Series or parallel? Yes, Shavit. What is this combination? When you connect all positive charges, positive plates to positive terminal, and when you collect
Series.
series,
No, sir,
okay,
parallel.
yeah. So you see that this is very important. That is why I keep repeating these ones. So let's say this is negative, this is positive, this is negative, this is positive, and this is negative. So when you connect all the positive ones to the positive terminal and negative ones to the negative terminal, then it becomes the parallel combination. This was the idea. So always remember this, right?
So, sir, like if you are connecting in them in negative to positive, so it will be series.
Yeah, so you see in this condition, so you have this capacitor, and then you connect this capacitor, and then you connect this capacitor. So you are alternatively, so this is positive, right? And this is negative. And this is positive and this is negative. So you have alternate negative ones are connected with the positive ones, right? Negative ones
Yes.
connected to the positive one. So in series, the alternate are connected, right? Similarly, when you study the current, then you will see that all the so when you connect all the positive terminals to the positive ones, so that will be the parallel combination. This applies everywhere. Okay. Okay. So keeping that in mind, we were doing this problem, right? So let us quickly finish this part, and then we do the rest of the questions. So those kind of questions are very important. So first one, we were solving this one, right? So this question we were solving. So question on, so this was the question on parallel plates, right? Combination of parallel plates, right? So this has the distance between the place G and the area was A, right? And you can see that this positive one, this positive one and this positive one is connected to the positive one. And then this negative plate and this negative plate, it is connected with the negative one. So this is what kind of combination?
Parallel.
Parallel, right? And you see that how many capacitors do we have? So plus and negative sets. This is one, negative and plus sets. So this is two, plus and negative sets. So we have three capacitors. And all their areas and their distance between the plate is same. So the effective diagram, right, effective diagram would be this one. So this is the effective diagram, right? And if we calculate the C effective, so this area is, let's say this is C1, C2, C3. So effective C would be in parallel, that is the sum, linear sum, right? So if we calculate C1, C1 area is A, and there is space between the plates and distance is T. C2 is AE naught by D. C3 is AE naught by D. So this would be how much? This would be simply AE naught by D plus AE naught by D plus AE naught by D. So
3
this
in
3 AE naught by D. So this is the C effect. Right. Please note it down and then we'll do the next question. So now we will speed up. We will quickly do the questions. So quickly note it down and then we'll do another question similar to this one. So whenever you have noted it down, please tell. Yes, whenever you have noted it down, please tell. Noted, Chavez.
yes, sir. One second.
Okay.
Done, sir.
Okay. So the next question is like same combination, but you see what happens. So the in this question, what we will do is that we will connect them in a different way. So now I connect this one and this one, right? This one and this one with the positive terminal, and then I connect this one and this one with the negative terminal, right? So this will acquire the positive charge. This will acquire the negative charge. Correct. This will,
Sir,
yes, yes, yes.
sir, can you repeat? Just I was out now.
Yeah, yeah. So you see that this, okay, so let me start from where did you go? So when did you go away?
So now listen.
Yeah, yeah. So you see that we had these four plates and I connected the last ones. I connected the last one with the positive terminal and I connected the middle one with the negative terminal, right? So then whatever plates are connected with positive one, they will acquire the positive charge. So this will acquire positive and this will acquire the positive charge, right? This will acquire the negative charges. This will acquire the negative charge. So can you identify that which combination can give you the, which one is the positive negative combination, which can act as the capacitor? So how many capacitors are there in this question?
Sir, 2.
Two. Absolutely right. Good. So we have this one and this one, right? So this is negative, negative, so this cannot act as a capacitor. Good. So which means that this length is or this area is A and this distance is D. Similarly, this area is A and this distance is D. Right. So again, we see that positive ones are connected to positive one. Negative ones are connected to negative one. So what combination is this? What
It's a
combination?
parallel.
Parallel again, right? So the effective diagram would be this, right? And this is connected to the supply. So this is C1, this is C2. So C effective or equivalent would be C1 plus C2. So again, this would be AE epsilon naught by D plus AE epsilon naught by D. So this is 2 AE epsilon naught by D. Understood?
Yes, sir.
In
Sir, in
the,
the first question,
yeah,
the single plate was having both plus and negative charge. So we consider it as parallels.
yeah. So why did I consider it parallel? Because we had all the positive terminals connected with the positive ones, right?
In above one, there was negative also, right? In that, which was connected to terminal, positive terminal.
Where is so which one is which negative one is connected to the
No, sir,
positive
in
one?
above question, above question.
In yeah, this is the so this one is the lower one and this is the above question, right? So in this you see that all the
Okay,
positive
okay, sir,
ones.
sorry, sir.
So all the positive, yeah. So that is how we identify the. Remember, whenever all the positive ones are connected with positive, we say that that is parallel, right? Okay, so please quickly note it down, and then we will do the. So then we'll add the dielectric between the capacitors. So then you will see that how remembering the idea of this combination. How can we solve those questions? And those are very important questions, right? So if we know the idea, then that would be very. Whenever you have noted it down, please tell. Noted, Chavez.
Yes, sir, just a second.
Okay. Done, Chavez.
Done, sir.
So now let us do this question. And yeah, still without the dialect. So we have this plate, right? And then we have so this area is A, okay, and then we have this plate, right? And then this plate, and then this plate. Okay. So you have this plate, and this third one plate. And this is A by 3, right? This is A by 3, and this is A by. Okay. This is connected with the positive one. This is connected with the negative. So this is from where the plate starts, right? Now this distance is D. This distance is D2D, right? And this distance is 3D. Okay. This is positive 1. This is positive 1. This is positive, right? This is negative. So how many capacitors are there, Javed? Vinisha, who is yes, Shavez, how many capacitors are there?
Yes, sir. Three.
Three, right? So one is this one, and then from here to here, this is the second one, and from here to here, this is the third one, right? So, and how they are connected, series or parallel? Yes,
Parallel.
parallel, right? Good. So from here to here, you have one capacitor from here to here, and from here to. So C1 is area is A by 3, right? And
Yes.
epsilon naught, and this is D. So this is A epsilon naught by 3. This is my C1. Then C2 is A by 3 epsilon naught by 2D. So C2 is A epsilon naught by 60. Similarly, I have this C3. So this is again area is A by 3 epsilon naught by 3. So this is A epsilon naught by 90. And the equivalent diagram is this one. So we have this one. So and this one, and this one, and this is connected with the DC supply. So this is C1, C2, C2. So C equivalent would be C1 plus C2 plus C2, which is AE epsilon naught by 3D plus AE epsilon naught by 6D plus AE epsilon naught by 9. So if we solve this one, so AE epsilon naught 3D common, this is 1 plus 1 by 2 plus 1 by 3. So this would be AE epsilon naught by D 3 and 6 plus 3 plus 2. So this would be how much? So 11. So 11 AE epsilon naught by 18. So this is the theory here. Understood, Chavez?
Yes, sir.
Okay, so please, if you have any doubt, please ask me. Otherwise, please note down this question. Yeah, whenever you want me to scroll down the screen, please tell me, Chavez. So whenever you want me to scroll down the screen, please tell. Yes, done, Chavez.
Yes, sir. Just, sir, can you scroll down?
Yeah, whenever you have
Done,
noted.
sir.
Done. Good. So now let us do the questions on dialect. So now, questions on dielectric combination. So the first would be that, let's say you have this capacitor, and there is a partition like this, right? And the two dielectrics are placed like this. You have one dielectric which is this one, right? And then you have another dielectric, which is this one. So you have another dielectric. So this is looking same. Yeah, this is dark color. So this kind of combination, right? And this is connected to, let's say, positive terminal, and let's say this is connected to negative terminal, right? And then this is K1, and then this is K2. So this will have positive charges. This will have a negative charge, right? So can you, so this is your C1, this is your C2. So can you tell me what combination is this? Parallel one or series one? Yes,
Sir, is it parallel?
absolutely right. All the positive ones are connected to this one, right? And all the negative ones are
Yes,
connected.
sir.
So the equivalent diagram is this one, right? So this positive one connected to this positive one, and then you have this is dielectric, and then what was the other one? This is C1 with K1. This is C2 with K2. So now if we write C equivalent, that would be how much? That would be C1 plus C2. But how much is C1? So C1 is, now you see the total area. Total area is A. So what would be this area? Area would be how much from here to here?
A by 2.
A by 2, right? So this is A by 2. This is A by 2. So this would be area epsilon naught and K1 by D would be same, right? D is same. So D. So this is A E epsilon naught K1 by 2. And C2 would be similarly A epsilon naught K2 by 2D. So if we calculate C1 plus C2, this would be A epsilon naught K1 by 2D, and this would be A epsilon naught K2 by 2D. So we can take AE epsilon naught by T common. So this would be K1 plus K2 by 2. This would be C equivalent, right? And sometimes they may ask that what would be the equivalent dielectric constant. So then we can compare this with the A E epsilon naught K equivalent by D. And this is A E epsilon naught by D K1 plus K2 by 2. So this part cancels out, and K equivalent is K1 plus K2 by 2. This you can also calculate. So any doubt in this question?
No, sir, sir, that K1 is dielectric constant.
Yeah, K1 is dielectric, right? So this is K1 is dielectric constant. This is the dielectric medium that we have put between these capacitors, right? So only thing
Yes,
that
sir.
we have, yeah, only thing that half portion is this one, half portion. This is how we apply. So when we'll do the next question, then you'll see that there could be another scenario also. So whenever you have noted it down, then whenever you have noted it down,
Done, sir.
yeah. Okay, so now you have a combination like this. So you have these plates, right? And the dielectric are placed like this, and the other one is yeah, these are the two dielectrics that you. And this one is connected with positive one. This one is connected with negative. Right? So this is positive. This is negative. This is K1. This is K2. So to understand this, there would be a there would be a polarization. Then there would be a net charge generated in here. So this would be negative one, and this would be positive one. Okay. So now you tell me what
So
kind
how
of
did this plate came, sir? Yes,
these charges.
yes,
Yeah,
yes, sir. How did this charges come
yeah,
between?
because of the polarization, right? So this is positive one. So this will acquire a negative charge, this plate, and this will acquire a positive one. So
Okay.
this will attract the negative ones in here, and this will attract the positive ones in here, right? So then they will be oriented like this. Understood?
Yes, sir.
Yeah. So now can you tell me what kind of combination is this? This is area A. This distance is
Parallel.
parallel. So all the positive ones are connected to the positive ones. Yes. You see, this is the positive one. This is connected. This positive one is this connected to this one.
No, sir.
So this is parallel or series.
Series, series.
Good. So this is series. So equivalent diagram. So this is C1. This is C2. So equivalent diagram would be this and this. Right. So this negative one is connected to the positive one. Right. This negative one connected to the positive one. So this is series combination. Right. and this one is the green one, right? And this one is the
So let's say if the charge is positive and it's connected to positive terminal, it will be parallel.
yeah. So whenever you have all the charge, all the positive plates connected to the positive ones, so that is parallel, right? So whenever we see a combination where positive ones are not connected to the positive ones, so then they are series. Understood?
Yes, sir.
Okay, so let us write down. So this is K1, this is K2, this is C1, this is C2. Who is it? Text 1 minute. Yeah, so then we have to find out the equivalent resistance. So please find out, Chavez, now this time you do the calculation. So please find out C equivalent, remembering that C1 would be how much? C1 is area would be same, right? The plate's area would be same. So this is A E epsilon naught K1 by distance would be how much?
So d by 2.
D by 2. So this is D by 2. So this is 2 A E epsilon naught K1 by D. C1. Similarly, C2 would be 2 A E epsilon naught Q2 by D. So you have these C1, C2. Please find out C equivalent and tell. Yes. What did you get, Chavez?
So C, yes, sir.
Yeah. How much?
So I'm going to,
Yeah, your voice broke in the middle. So
sir, I'm going to finish.
yeah. So you said you are calculating.
Yes, sir.
Yeah. So please calculate and tell me what you get. So
Sir, can I do the answer?
Yeah, so this is this what you got?
Sir,
Yes. Is this the answer that you got? Yes, Shavis.
yes, same answer.
Your voice is breaking. Your voice is breaking, Shavis.
Sir, yes, sir, I got the same answer.
Good, good. So yeah. So please, did you note down the question?
Yes, sir.
Oh, you also noted this question. And the equivalent part?
Yes, sir.
Okay, so then,
Sir, can I go for Salah?
oh, you want to go for Sala, but okay, so let us do one more question and then because if everybody will be here, then I'll have to take 1.5 hour class. But only you are here, so I can take 1 hour class. But let us do one more question, and then after one more question, we'll end the class. Okay, Shavi, is that okay? Yeah, because when everybody will be there, then I'll have to take this 1.5 hour class. But only you are here, so we can take 1 hour class. But yeah, so we have 5 more minutes left, right? So then we can do one question. So yeah, can we do one question more, Chavez? Yeah, I cannot hear you.
Yes, sir.
Yeah, so let us do one more question, and then I will. Okay, the next question is like this. You have this parallel plate capacitor, right? And then you have this one, okay, this one, and then you have this one, and then you have this is K1, this is K2, and then this is K3. This is C1, C2, C3. This is connected to the positive one. This is connected to the negative. Right. So we have a mixture of combinations. Right.
Yes, sir.
Right. So this part, let's say this is some K4. Right. So this whole part is connected parallelly with uh, this is this is negative, right? So then this would be negative, this is positive. So these two are connected in series or parallel. Yes, Chavez.
Yes,
These
sir.
two, yeah. So these two are connected in series or parallel. These are K2 and K3, series or parallel.
Sir, series.
Yeah, these K2, K3 are in series, and this K1 and this whole one. With
Parallel circuit.
good, absolutely right. So the effective diagram would be this K2 and K3 in series, and this is parallel uh, with this one. So this is the effective diagram. Good. So this is our K3, right, and K3 is connected to, and then this is K2, and this is right. So this is K3, this is K2, this is K1, and then this is C1, this is what? This is C3, and then this is. So if we calculate C1, C1 would be total distance is D. So C1 would be A by 2 epsilon naught K1 by T. So this is AE epsilon naught K1 by 2T. Right, Chavez?
Yes.
And C2, so C2 would be A by 2, right? And epsilon naught and K2 divided by D by 2, right? So D by 2, so this 2 cancels, and we have this AE epsilon naught K2 by T. And similarly, we have this C3. This is also A by 2 epsilon naught K3 divided by D by 2. So by 2 cancel, and this is A epsilon naught K3 by. So these are the capacitance, right? So first we have to find out C equivalent, let's say 1. So this would be, let's multiply this C2, C3 divided by C2 plus C. So whenever we have two combinations, so we can do this, right? So
Yes, sir.
this, yeah, so this would be AE epsilon naught K2 by D into AE epsilon naught K3 by D divided by AE epsilon naught K2 by D plus AE epsilon naught K3 by D. So AE epsilon naught by D common, right? K2
Yes, sir.
AE, and this is common, and this is K2 plus K. Right, so this part cancels out, and we have AE epsilon naught by D K2 K3 divided by K2 plus K. This is C equivalent 1. Now the equivalent, so the effective diagram is then we have this one CQ equivalent 1 and C1, and this is connected to this that. So then C equivalent would be C1 plus C equivalent 1. So C1 we have calculated, which is AE epsilon naught K1 by 2. So AE epsilon naught K1 by 2D plus AE epsilon naught by D K2 K3 by K2 plus K. And we can take AE epsilon naught by D common. So this is K by 2 and K2 K3 by K2 plus K3, right? So this would be how much? This AE by D is there, and LCM is 2 K2 plus K3, right? So then this would be K1 and K2 plus K2, K1, K3 plus 2K2, K3. So this would be the answer. Okay, this was a very lengthy question, but we have to just understand. So any confusion in this, Chavez? Any doubt?
No, sir.
Okay, so please note it down from here.
This I did.
Oh, you already did.
No, sir. Answer I have to copy.
Yeah, so okay, please note it down. Yeah, so whenever you want me to scroll down the screen, you please tell. We are calculating C equivalent in C2 and
So can you scroll down? Done, sir.
Done. Okay, so yeah, we will stop at here, right? But whenever other people join, then the class would be of 1.5 hours because only you are here. So okay, but I will give you a question homework, right? So you have this capacitor, and the dielectric is connected, or so dielectric is connected like this. This is one dielectric, and then this is the other dielectric. So this is the other dielectric. Okay. So you have this. This is K1. This is K2. This area is A, and this is theta, and this distance is t. And this is connected to positive one. This is connected. So you have to find out C equivalent.
So here you have to
So please
integrate.
take this. Yes,
So here you have to integrate, right?
yes, yes, absolutely right. So did you do this question before?
Yes, sir. Earlier you gave one question, sir.
In where? Uh,
Sir, in this capacitor only, sir.
oh, in the CBSE course.
No, sir. You did that question.
I.
Yes, sir. Not with dielectric. Without dielectric.
Oh, without the dielectric. Yeah. So, oh, this is yeah. So this is the dielectric with the dielectric, right? So this question is with the dielectric. Okay. So yeah, I will stop it here and see you in the next class, Shabit. And all the best. Oh, so your exam has time. Okay.
Yes, sir. I'll just note.
Yeah. Please note down this question.